I went shopping on AliExpress again, and usually that ends in one of two ways. Either you get something for a huge discount, or you just receive absolute garbage and you question your entire life. This one, I have no idea where it's gonna end up with. This is supposedly a full 3D printer that I paid just 72 euros for, and considering that you can easily spend that much money on just a 3D printer nozzle, I think this is gonna be at least very, very interesting. The first 3D printer that I built cost over 1,000 euros in parts, and it was not very good. And I think 72 euros sort of fits in that weird middle ground of like not being totally free, but also being eerily close to like an Ender 3 on sale that you can get for like 100, 150 bucks. So they're gonna have to cut some corners. So I wanna know, is this something that you buy just for the parts, or is this something you could actually genuinely use as a 3D printer? And we're gonna dig in right after a message from today's sponsor. The Anycubic Kobra 2 Pro is an affordable option to get you into high-speed printing. With hot end flow control set up out of the box and accelerometers in the printhead and in the bed, it can get you better prints even at high speeds by measuring and correcting for resonances in both axes. Use the app to browse and print models, or plug a webcam straight into the machine to monitor and time-lapse your print jobs. With a new smart automatic Z offset, the Kobra 2 Pro is super easy to set up and use, and you can find more info at the link in the description below. Alright, so these come in the typical trash bag package, and I've already dug in a bit. I was kind of worried that the package was like really small. But yeah, let's just see what we got. So this is the Easy 3. I don't know if this is supposed to be Easy 3D or something. The K9. Doesn't look like there's a dog in here, but yeah, it's a blue one. That was the cheaper one. It's quite the small package. Isn't that cute? That is the entire print bed, and it looked like this was going to be a heated one. It does have sort of the magnetic surface, but look at that. That is so soft, and it's also extremely light. This obviously is not a heated bed at all. So flimsy. Wow. Quick start manual, a full operations guide. That's more than you get with a bunch of printers these days. That's the entire power supply. This is 24 watts for the entire machine. 24 watts, that doesn't even cover for the hot end. Wow. Little trash of filament. Parts. This is all so soft. Interestingly, you get 2 SD card readers. And then this is sort of the entire 3D printer. This is similar to what you get on the Snapmakers, where it's just 3 identical axes for X, Y, Z. And I guess these just, yeah, you can just clip these together somehow. I'm not going to try and do this right now. Well, I will. There we go. These just snap together. And my thought was like, hey, if this printer sucks, I can still at least use these for like a simple linear axis, because the ones on the Snapmaker are all proprietary and you can't drive them outside the printer. Oh, wow. You can see how far the cost-cutting measures went, because they're not even using like solid rods. They're using tube, and this feels like it's nothing. But I guess it's better than using like plastic guides and writing straight on those. But yeah, I was wondering like why this thing was going to be so lightweight. Now, there's one thing missing from these linear units, and that's any sort of end stop. They're using a tiny, like this is less than NEMA 14 size. They're using an absolutely minuscule stepper motor, but there's no end stop. So I'm guessing to home these, they just run them into the end and let the motor skip. Guess that works. Save some money. And then this is sort of the 3D printer base and the tool head. And the tool head looks... Actually, I think that's the best looking part of the entire machine. This looks pretty good. There's a little silicone sock on it. Oh, can you flip this open? Yeah, the cover just comes straight off. Oh, it flips up. That's actually kind of cool. So that's the entire hot end and feeder unit. And honestly, that doesn't look half bad. I do want to take out the silicone sock. There we go. Look at that. It's got a little ceramic ring heater with a thermistor bead sort of on the outside. But that doesn't look too bad. I mean, with 24 watts in total available for the entire machine, they got to save power somewhere. And I guess this is, yeah, this doesn't have a lot of thermal mass, so it's going to heat up relatively fast, even if it's just a 10-watt hot end. It does have a part cooling fan with a bit of an air guide down here, and that also doubles as sort of a stepper cooling fan. So that's kind of cool. There's no adjustability to the extruder at all, which is standard practice these days, really. Also, there's more strain relief in here with the wrap that's sort of captured than on a lot of other printers, so that's sort of ridiculous. This thing goes back on. Oh, this even has a clocking. Not that it matters. Now, the last thing to look at is this printer base, and obviously this is also all plastic, and this is more buttons than I thought I was gonna get, because obviously this printer doesn't have a screen on it. There's no way to really interact with it. It does have a micro SD, a trans flash slot. Somehow you are able to put files on the printer and have it print by itself, but obviously with no way to select which file. This is, I guess, the interface they came up with. Buttons that are labeled 1, 2, 4 and a play button. There's also a switch for feed and retract. And obviously it also has the power port and the USB, so you can print with it with like Octoprint or just a printer host on a PC. I do want to know what's in here, because this looks sort of like a standard mainboard, but that even looks like it has a Wi-Fi antenna printed on it. Okay, let me dig in here. So they do include a screwdriver, which is very handy. It's the wrong size, it looks like. Yeah, I'm gonna bring a proper one. Oh, I'm just noticing there is another button on the back which has a little home symbol, so I guess that's the home switch. So there's 6 buttons on the entire thing. That's quite a lot. So let's see. Huh. Oh, so I guess this is their sort of standard mainboard that they use for everything, and then they can plug in different communications modules. What I was seeing from the outset was this little print down here, which very much looks like a Wi-Fi antenna, but I guess they just plug in different modules here depending on how much interface they're giving the user. So I'm thinking like somewhere on here there must be some serial interface that you can just plug into. And we've got our 4 sort of standard HR4988, which are the Allegro clones, so they're very standard drivers. The tiniest little wires for the hot and actually, looking at this, there's a MOSFET for a heated bed, so you could very easily retrofit that if you give it a bit of a more powerful power supply. And in here we've got a 32-bit, an AT32F403, so that seems to be some sort of STM32 clone. That's pretty cool that you're getting a 32-bit mainboard for 72 bucks. That's very nice. So obviously in terms of like fusing and stuff, there's not really anything in here, but considering we just have a 2 amp, 1 amp, 2 amp 12 volt supply, I don't think we're gonna need much of that. The power supply is gonna do all the fusing you're ever gonna need. So let's get this thing back together and get it built and get it printing. So you get this quick start guide that is like, new 3D printer user must read the first children level. They're selling this sort of like a kid's toy, but honestly, you know, kids' toys should be fun. They should be usable. And I'm going to look at this as if it was a real printer because it has all the parts to one. So yeah, the assembly of this printer is pretty straightforward because it's all just either you clip it in here or you clip it in here. And essentially you just take this part, you slide it this way around, you slide it in here. There we go, that sort of clips in. And then there's one screw in the bottom that they're including that you sort of fix this stuff together with. Must be fixed tightly, they're saying, so yeah, okay, that's pretty wobbly, but you know, it's gonna sit on the ground. Somehow it's very light though. And then essentially we just get one cable that we plug in and that's it. That's the Y-axis done. Then the bed has this same sort of mechanism. So that just slides in the side like so. Ah, crunchy. And then you can just sort of thread one screw straight through the bottom here that locks this in place. But I don't think the screw actually does much because this is already clipped in place. Okay. It looks like they're actually using sort of different connectors for the different parts. So you can't just stack axes onto each other. Like this end connector really doesn't do anything with this side one. So I wish that would have been just a standard connector that you can use to make up your own sort of kinematic stuff. But yeah, like this, and this is just going to fit in the place it's supposed to go. It doesn't click in quite as satisfyingly as the others. Don't want to strip it, we're just going into plastic. Which way does this go? Like that. Oh yeah, this is fully cantilevered, right. Like that. And then one more screw here. Oh yeah, I think that one's stripped. I don't know, it's not very confidence-inspiring so far. And then lastly, the tool head just goes on like that as well. Okay, last screw. Okay, so x-axis goes here, z-axis goes there, and then we get a little filament holder that goes somewhere. That doesn't fit a full-size filament spool, does it? It does. It looks like it's gonna break, but like it does absolutely fit. Where does this go though? Oh, this manual actually is just like 5 pages and then it starts over in Spanish. Okay, put it on and press it down with your hand. And press it down. And then I guess like you're supposed to use that for filament? I mean, that doesn't really do much. Okay, so I think I just figured out what all the buttons on the printer do. You get the play button down here. This is one. You get the home button in the back. And you get the 1, 2, 3, 4 buttons here. And those 1, 2, 3, 4 buttons actually move the nozzle to each of the 4 corners of the bed. Because you have, this manual leveling. There's no auto leveling on this thing, obviously. You have 4 buttons to get to those corners. That's actually very convenient. Yeah, I was wondering, like, how do you level this thing? How do you preheat it? There's obviously no display or anything, so I have no idea what the printer's trying to do, but it's going to do something. And then that plugs in here. Fan spinning. Play button's glowing green. Oh yeah, it is heating. You can smell it. It seems to be heating up. No? Is it? Oh, that's a fan you're smelling. Ah. So what if I press home here? Let's see what happens. Yeah, it's doing exactly what I was thinking it was going to do. It just runs into the end and has the motor scale. Does that work on the z-axis? It does. Okay, I guess we're homed. So that means we're already at position 1, so we just need a piece of paper. It feels like absolutely nothing. Let's try 2. Is that the actual usable print area? I don't think so. Why? He's so far off. So obviously this is not going to be a heated bed. I have no idea how well this sort of super flexible plastic mesh material is going to stick. And then of course you end up with little nubbins on the bottom of your parts, but I mean if it works on an unheated bed, then yeah, I'm going to take every trade-off I can. Oh, so when you press 1 it rehomes. Okay. So how do I actually load filament on this? Before feed you need to make sure there is at least 3 centimeters space between the nozzle and the platform. Press print button and hold for 3 seconds and release. The printer head will raise 1 centimeter each time. That's quite a lot of functionality from just one button. Huh. It's sort of like the press and hold to adjust Z on the pusher machines. Shift the gear, so switch the lever, switch the switch on the side. Blinking fast indicates that the nozzle is heating up. The light turns to blinking slow once it's heated up and the motor gear starts to turn. So it actually has a filament feed procedure. And then once you're done, just move it back to the center. Okay, let me just get a filament that is a bit brighter than this. I think I'm just going to use the included like 10-meter sample. For these test prints, I think that should be just about good enough. So one thing that's actually kind of cool is that the side of the extruder is just covered with clear plastic, so you can absolutely just see into where the filament is. That's actually pretty well made, I think. I think that the tool head is the best part of this entire machine. I mean, obviously. So I'm going to switch this to feed, and then we're blinking fast. So I guess it's just going to start feeding once it's up to temperature. There's no... I guess you could press the button. They could have implemented it like that, but it's just going to keep feeding until you tell it to stop. Now these belts that they're using on all 3 axes, they are minuscule. They're like 3 millimeters wide. They are genuine Gates Power Grip GT though. I mean, at least it says so on the side of the belt. They are properly tensioned, so that's good. We're blinking slowly, and I guess, yeah, it's feeding. Oh, wow. It is gripping and it is pulling. There we go, there we go, okay. The smell of cheap perfumed PLA. I guess that's gonna cool off again. So hold on, to print something, we're just gonna see what's on here. Yeah, okay. That seems to be doing something. What I don't like though is how open everything is, like all the wiring in the back. This Y wiring, is, especially this one, gets caught in the bed quite easily, and if you put it underneath, like the printer's going to rest on it. So you really don't have a choice but to just have it dangle on the back here. Oh yeah, there's the homing procedure. Okay, that is violent. Okay, it's priming. That looks like the Z height is pretty much spot on. God, that cheap. I don't know if it's the filament or if it's the harden and stuff just heating up, but it smells horrible. Looks like it is printing with a raft though, so that makes sense considering that you would otherwise have that textured pattern on the bottom of your print. So yeah, it looks like it's printing. I'm gonna catch you all once this print is done. It is relatively noisy and it does smell pretty bad, so I'm gonna get out of here. So that's the first print done, and it's not looking as horrible as I was fearing it could. There are some issues where like the feed rates transition from one speed to another, and here up top it almost looks like a layer shift, but that could also just be overhangs and issues like that. Overall, layers are stacked reasonably well, and you know, this is a good starting point. So that was the pre-sliced G-code, and while I was printing, I had a look at that G-code and tried to replicate it in Prusa Slicer, and we've got a 3D Benchy sliced with essentially just lower speeds than usual. You don't have any control over the part cooling fan, so that's just always on. So let's just see how that prints, and that should give us a pretty good indicator of what the strengths and weaknesses of this machine are. So there's our finished print. I mean, it doesn't look great, but it could have also looked a lot worse. The stringing, I think, is just from the temperature setting or my retracts not being dialed up enough, or it might just be the white filament. White PLA is just the worst one for this sort of stuff. The layers are nicely stacked. It does have cooling issues, definitely, so the bow is really bowed in and the overhangs don't turn out nicely. Something that can be solved with just a bit of a printed upgrade right there. The bigger issue that I have, and you can see that up here in the chimney, is that this motion system really isn't great. Like the injection molded, I think these are Delrin bushings. These have quite a lot of play, which actually isn't the problem at all. Because with a cantilever design like this, all these bushings are preloaded. So these always pull like that, the tool head pulls like that, and then the bed just sits flat. So really backlash in the bushings isn't nearly as much of an issue as you might think. So in these bushings, you can see straight through them. There is a gap between the bushing material and the rods, but that's not really an issue. The bigger issue is the fact that they used geared motors for all the axes, and the gearing has a lot of backlash in it. So if I move this up, you can actually see how much, you know, that's half a millimeter of backlash in the motor itself, and you can hear it in there. So that definitely is going to cause some issues, and backlash like that is just super hard to compensate for through slicer or firmware settings. Speaking of firmware, I did plug this into the computer real quick to just see how it's going to behave, and it does behave like a Marlin 2.0. It reports as being a Robin Lite with no further information. A Robin Lite is an MKS mainboard, which I don't think this is. Standard Marlin doesn't support the CPU that they're using here, and the Robin Lite also uses a completely different CPU. So they did something to make it work with this weird STM knockoff, but upgrading firmware on this and trying to set up compensation and stuff, it's probably not gonna happen. Okay, yeah, so this spool holder, they don't want you to use a full 1 kilogram spool. You're supposed to use the smaller 250 grams, which are like the trial sizes that are included with printers sometimes. I think that's also going to be an issue. Loose filament really is the only thing you're going to be able to use, again, because of all the backlash. As soon as this toolhead tries to pull on any size of spool, you can see how much that is moving around. So any little force on the filament is really going to mess up your print. Something like a reverse Bowden in here is going to help this out a ton. Make no mistake, this printer is a piece of shit. Like, this is not a good printer, and I wouldn't recommend anyone buying it. But I do kind of like it for the fact that they managed to make it so cheap, and they did a lot of things in a good way. The fact that they're using hollow rods saves shipping weight, saves material. The fact that they cut out the LCD screen and just gave you 6 buttons and a switch. That's literally all the UI you need on a 3D printer. Even with something that has like a full touchscreen on it, like the Anycubic one, you're mostly just going to use it to you know, plop in an SD card and start that print. Homing with the 4 buttons in here, really that's all you need from a printer interface. The hot end and extruder seem to work pretty well. It is tuned to run at really low accelerations with this entire thing. I did put a thermal camera on this thing and the motors were at like 60, 65 degrees Celsius. They do mount up to a metal plate, so at least it's not warping the plastic directly, but I wouldn't push these any harder. Maybe with better drivers, this thing would run a lot smoother and could even move a bit faster. One thing that I find sort of hilarious is that they give you upgrade options for this. You can buy upgrades for this printer. One of them is a heated bed that you can add on. And even though the main board has the MOSFET and the control loop and everything set up and right there, instead they're giving you a separate control box that you get a separate power supply with. So I guess as soon as you plug that power supply in, your heated bed is just going to heat up to like 45, 50 or whatever degrees. And you have no control. So I guess that option of just giving you a second one of these power supplies was cheaper for them than to give you a single supply that replaces this one and have you wired it into the board. So everything about this printer is not really done poorly because they didn't know what they were doing. They were just trying to build it as cheaply as possible. And I respect that. I kind of like how shitty this thing is, and I want to do stupid things with it. So my thinking right now is it would be hilarious to put a full-on clipper mainboard in here and just have this thing hoon like crazy. I would need to do some mechanical upgrades to support that, but I think that would be very funny. Let me know if you have any other ideas for this setup. I don't want to like completely replace the printer. It still needs to look the part. It still needs to look like a cheap toy printer, which it absolutely is. I think it would be hilarious to show up to something like Murph with this and yeah, just going like, hey, look at my 72-euro printer, and it ends up demolishing other people's speed Benchy records. You know, that would absolutely make my day. So let me know what ideas you guys have. Again, this isn't supposed to be a totally serious project, but I think it would still be a good project to work on, something to learn stuff, something to look into new projects like Clipper and just figure things out. And of course, there are going to be challenges, but you know, solving those is all the fun. There's going to be a link to AliExpress for this in the description below. Really don't buy this one. Buy something a bit nicer instead. Hope you still found this interesting. I certainly did. Thank you all for watching. Keep on making, and I'll see you in the next one. Bye.